Hello everyone, and welcome to the lists lecture. So in this lecture we'll be learning about the list data structure in Python. And we discussed earlier that strings are a type of sequence in Python. And we're going to learn now that lists can be thought as probably one of the most general versions of sequences in Python. So let's go ahead and get started. Here I have opened the Jupyter notebook. And we're going to learn about creating lists, indexing and slicing lists, some basic list methods, and then nesting lists, and we'll get a quick introduction to list comprehensions. So this is a quick overview of everything in this Jupyter notebook. You can go ahead and check it out. But let's go ahead and dive into the live code. All right, here we go. So now we're in the live code. Let's go ahead and assign a list to a variable. So I'm going to create a variable name called my_list, and I'm going to create a list. So lists are constructed with square brackets, and then they have commas separating every element in the list. So for instance, if I wanted to make a list of the numbers 1, 2, 3, so right now in this format, my list is everything in between these two brackets, and it allows me to keep track of this sequence of elements 1, 2, and 3, and they're all separated by commas. Shift enter to run that cell. So we just created a list of integers. So if I say my_list, and I can remember to do tab to autocomplete, there I have my list output. So as I mentioned, this is a list of integers, but what's nice about Python is lists can actually hold different object types. So for instance, I can create my list and I'll set it equal to a new list. And this list is going to contain a string, an integer, 23, and even like a floating point number, so 1.2, and let's put another string in there for good measure. There we go. And now if I call my list again, you can see the list is holding different object types. So it's holding a string, it's holding integers, floating points. So lists can hold different object types. You can go ahead and mix and match them within the list. So just like strings, there's a length function, and the len function also works for lists. So I can say len of my list, remember tab autocomplete, and there I get the list's length is 4, and that's because there's 4 elements. There's the string, 23, 1.2, and that O string. Okay. So let's go ahead and jump into indexing and slicing. So indexing and slicing is going to work just like we explored indexing and slicing in strings. So let's go ahead and make a new list, or just reassign that list label. So I'm going to make a list of 1, that's string 1, 2, let's say 3, and then let's go ahead and put in some integers to mix it up. So 1, 2, 3 in strings, and then 4, 5. Remember, each of the elements is separated by a comma. So since this is a sequence, I can index and grab stuff in that sequence. So if I say my list, that variable name, with brackets and then 0, that's going to grab the element at index 0. And in this case, it's just that first one is that 1. So just like in strings, the notation is the same. So whoops. Let's say I want to say my list, and let's say I wanted to grab index 1 and everything past it. I can use that same colon notation, so my list, grab everything at element 1 and then everything past it. So that's 2, 3, 4, 5, because remember at index 0, that's the 1 string. So let's say I wanted to grab everything up to index 3. I can say my list, and I'll say everything up to element 3, so colon 3. And that returns 1, 2, 3. Great. So we can also use the plus symbol to concatenate lists, just like we did for strings. So if you remember from the string lecture, I could say hello plus space, let's say world, and that would concatenate it into a single string hello world. So I can actually do the same with lists. So I can say my list, and that's just the 1, 2, 3, 4, 5 there, and I can concatenate it with another list. So I'll create a new list and concatenate it. So what I have here right now is this variable, my list, my underscore list, representing my list, and I'm going to add or concatenate this list consisting of a single item, which is just a string here, and that's denoted by those square brackets. There we go. And if you notice, when you concatenate it, it basically kind of just appended it to the last item on that list. Now again, it's important to note, since we're not reassigning anything here, if I just copy and paste my list here, that list hasn't been changed because I'm not reassigning it. Okay, so if I wanted to make the change permanent, I would have to reassign it. So I'd have to say my list is equal to my underscore list plus, let's say, permanent add. And now if I check what my list is, here I've added it permanently because I've reassigned it using that equal sign. All right. So we can also use the multiplication or the asterisk symbol for duplication, just like we did in strings. So I can say my list multiplied by 2, and that's basically going to just double my list. So 1, 2, 3, 4, 5, permanent add, and then again 1, 2, 3, 4, 5, permanent add. And you'll notice the output is just a singular list of the elements twice over. So again, that's not permanent since I'm not reassigning anything. If I just call my list again, I get that original list. Okay, so if you're familiar with another programming language, you might start to draw parallels between arrays in another language and lists in Python. But lists in Python tend to be more flexible than arrays in other languages, and there's usually two good reasons for that. They have no fixed size constraint, so for instance, this list, it can be as big as we want and we can keep adding to it. So I don't have to set any restrictions beforehand. I don't have to say, hey, this list is going to be 5 elements long in the sequence. Python allows us to just keep adding and growing to that list. And like we saw, what's nice about lists in Python is that they have no type constraint. So you saw earlier I was mixing strings and integers and floating points and different object types into that list. So let's go ahead and explore methods for lists. So I'm going to say L is equal to the list, square brackets, 1, 2, 3. So here I have my list, L, equal to 3 elements, 1, 2, and 3, in that sequence. So one method we can use is the append method. It's going to be one of the most common methods you use on a list. So again, the way methods work is you take that variable or label name, put a dot, and then type in the method you use. So in this case, the method I'm going to use is called append. And then append looks like this, has closed parentheses, and the argument you pass into it is the item you want to add to the end of the list. So for instance, I want to add a string called append me. And if I look at the list now, L, you'll notice I've appended to the end of that list that append me string. So just to reiterate again, since we're using the Jupyter Notebook and it's such a great tool for learning, if I say L dot and then click on tab, it'll give me a list of all the available methods. Go ahead and check out the advanced list lectures for a breakdown of a lot of these methods, but we're going to go over a few of them in this lecture as well. And again, I can say L.append, and since we're using the Jupyter Notebooks, I can say Shift Tab, and it will give you the doc string and some additional information. So it'll tell us L.append, you put in the object, and you can append object to the end. Great. So right now we have L is equal to 1, 2, 3 append me. Another method that's commonly used in lists is the pop method. So you can use pop to basically quote unquote pop off an item from that list. So by default, pop takes off the last index, but you can also specify which index to pop off. So what I'm going to show you is just a quick example. So I can say L.pop, and that basically returns that last element in your list, and it also permanently affects your list. So it just says, okay, I'm going to grab off that last item, pop it off, and then return it back. So let's go ahead and say I'm going to say x is equal to L.pop, and I can also specify which index. So by default, the index is -1, which would be your last element in that list, but I can pop off whatever index I want by passing it through. So let's say I wanted to pop off the 0 index item, which in this case would be 1, that very first item. So here what I'm doing is I'm saying L is my list, call the pop method on it, that .pop, and then I'm passing the index I want to pop off, which would be 0, which corresponds to that 1 element. And I'm using the equal sign to set that equal to a variable here. Great. So if I check out what x equals now, x is equal to 1. And if I check out my original list, L, I notice now it just consists of 2 and 3. Okay, great. So it should be noted that list indexing will return an error if there's no element at that index. So for instance, right now my list consists of the elements 2 and 3. So let's say I call index at 1, that should return 3. Remember, indexing starts at 0, so 0, 1. But let's say I said index of 99. So that's going to return an error, and if we read the error right here, it's an index error, and that's because the list index is out of range. So that makes sense. We can't index something that's out of range in that list. Okay, so let's go ahead and make a new list to explore 2 more methods, sort and reverse. So I'm going to say new underscore list is equal to, and in this case I'm going to use strings, just letters. So I'm going to say A, E, let's say X, B, and C. And the reason I'm not just doing the straight alphabet is because I'm going to show you how to sort and reverse some of this. So go ahead and make a new list that looks like that. Let's go ahead and make sure everything worked. Okay, so here's my new list. Remember, we're just using square brackets. The elements are separated by commas. So what can I do as sort and reverse methods? So if I check out new list dot and tab because I'm in Jupyter Notebook, I can see that there's a reverse method here. So let's go ahead and click enter and see what happens. As you might suspect, it reverses the order, and it's a permanent change to the list. So now it's reversed the order of that list. And what if we wanted to sort that order? Then I can say tab, let's go down to sort. And now if we check out that list, it's been sorted into alphabetical order, A, B, C, E, X. Great. So in the case of numbers, if that list was full of numbers, it would sort them in ascending order. All right. So another great feature of this data structure in Python that is the list is that they support nesting. And you'll notice a lot of data structures in Python support nesting. So that means you can have data structures within data structures. So for this example, we're going to do a list inside of a list. So let's get a quick look at how this works. I'm going to make 3 lists. I'm writing right now, well, let's say L underscore 1 is equal to 1, 2, 3. I'm going to say L underscore 2 is equal to 4, 5, 6. I'm going to say L underscore 3 is equal to 7, 8, 9. Okay, so I've created 3 lists, and I can actually make a list of lists. So I'm going to make another object called matrix, and I'm going to set it equal to a list of lists. So I'm going to say this matrix is a list itself, but I'm going to put in the elements as lists. So I'm going to say L underscore 1, L underscore 2, comma, L underscore 3. So now I can treat this as a matrix, because if you notice here, I have my list, which is the matrix, and the elements inside of it are actually lists as well. And this is what we mean by nesting data structures. So I have a list inside of a list, and this can keep going deeper and deeper. So you can have a list inside of a list, which is inside of another list. So We can again use index to grab elements, but now there's going to be two levels to that index. So the items in the matrix objects and then the items inside of that list. So I'll show you what I mean by that. So let's say I have my matrix object, which is just that list of lists, and I say index 0. So what's that going to return? That's going to return the first element in that matrix object, which will be 1, 2, 3. All right. So now that I have this first item in the list, I can actually index it again because it is a list. So I can say grab the first item in that matrix object and then grab the first item or element in that list itself by putting another pair of brackets there. So you can see that I have multiple levels to this indexing, and I'm just kind of exploring them there. So I encourage you to kind of play around, see how I can get this number 5. How would I do that? So in matrix, that's the second list or element, so I'd have to say 0, 1. And then within that one, that list, it's 0, 1 again. So that should return 5 there. And for another quick example, let's say I wanted to get 7. How would I get that? Well, we note that it's the item at the second index, right? 0, 1, 2. So it's that third item at index 2. And then 7, it's the first one, so that's at index 0. And if we get that, there we have the 7. Excellent. So I'm going to give you one last topic in this lecture, and that's going to be list comprehensions. So Python has a pretty advanced feature called list comprehensions, and it allows for quick construction of these lists. So I'm just going to give you kind of a quick sneak peek at what this looks like, but don't worry if you don't understand it because we have a whole entire lecture devoted to list comprehensions. But in case you're familiar with another language or you've kind of gone through a tutorial of Python before, I'll show you how we can build a list comprehension by basically deconstructing a for loop within brackets. Now I know we haven't gone over loops or anything, so if this doesn't make sense to you, don't worry about it at all. We're going to go over loops, statements, list comprehensions in much more detail in the future. But just for a cool sneak peek, let's say I wanted to create that first column of that matrix. I could say first underscore call as my object name and set it equal to row for row in matrix. Now I know if you haven't seen any for loops or any statements, this doesn't make too much sense, but don't worry about it. What this is basically breaking it down is I can create a list by kind of writing a flat for loop within the brackets. So we'll have lectures devoted to this in further detail, but just to give you kind of a sneak peek at what this is doing, I just created an object that consists of the first column of that matrix, that 1, that 4, and that 7. Okay, so what that basically did is just said, hey, for every element or row in that matrix, grab the 0 index of that row. And then using this list comprehension, I can actually make a list out of it. Okay, so that's a little sneak peek. We'll hit that in much further detail in the future. But just a quick overview of what we've done. I'm going to hop over back to the Jupyter Notebook. We've understood how to create a list using brackets and separating the elements by commas. We understand that a list can hold different object types such as integers and strings all mixed together. We can use the len function to check the length of a list. We can use indexing and slicing just like we did for strings because it's a sequence. So we can use those square brackets on that list variable to go ahead and grab things from that list. We can concatenate lists using the plus sign. We can use the multiplication or the asterisk sign to multiply or duplicate lists. And then we went over some basic list methods, the append method, the pop method, sort and reverse. And then we saw a quick introduction to nesting lists. Okay, so that's it. You can go ahead and check out the advanced list section later on in this course to go over some more details of those methods. But that's about it for lists for right now. All right, thanks guys.